Picture a small machine, alone on a cold red desert, farther from home than anything we have ever built that still answers when we call. Tonight, we are going to roll slowly across the surface of Mars, and we are going to see that world through the eyes of the little robots we sent there. NASA built 2 of them to last for only about 90 days and to travel about 1/3 of a mile, no farther. One of them lived for more than 15 years and drove the length of a marathon across another planet. And the thing that finally told us Mars had once been soft and wet, a place of rivers and standing water, was not a triumph at all. It was a broken wheel, dragging a long scar through the dirt. How does a machine the size of a golf cart outlive its maker's hopes 20 times over? How do you land something so fragile on a world you can never touch? And why would a stuck, dragging wheel become the moment we finally learned this dry red place was once alive with water? If you find a quiet comfort in drifting off to the machinery of distant worlds, you might gently tap the like button or follow along. There is nowhere you need to be and nothing to solve. So settle in, let your shoulders drop, and let us begin. To understand the rovers, we have to begin with the place they were sent to. We have to begin with Mars. It hangs in our night sky as a small, steady point of red light, and it has done so for as long as there have been eyes to look up. Ancient people watched it wander among the fixed stars and gave it the names of their gods of war, because of its color, the color of rust, the color of dried blood. For thousands of years, it was only that, a red ember, drifting slowly across the dark, far beyond reach, far beyond knowing. Mars is a small world. It is only about half as wide as the Earth, a little more than 4,000 miles across. If the Earth were a basketball, Mars would be about the size of a softball resting beside it. The gravity there is gentle, only about 1/3 of what holds you in your chair right now. So a person who could somehow stand on its surface would feel light, almost buoyant, as if they might bounce away with every step. It is a cold world, and a dry one. The air is thin, far thinner than the air on the highest mountain you could ever climb, and it is mostly carbon dioxide, the gas we breathe out, not the kind we breathe in. The sky there is not blue. In the daytime it is a soft, pale butterscotch, the color of weak tea, because of the fine dust that hangs forever in the air. And at sunset, strangely, beautifully, the colors reverse. The sky near the setting sun turns a cool, gentle blue. A day on Mars is almost exactly the length of a day on Earth. Scientists give it a special name to keep the two from getting confused. They call a Martian day a sol. A sol lasts a little less than 25 hours, just 39 minutes longer than one of our own days. So if you lived on Mars, your mornings and evenings would feel almost familiar, almost like home, just slightly stretched, slightly slower. But a year on Mars is much longer. Mars sits farther from the sun than we do, so it takes a longer, lazier path around it. One Martian year is about 687 Earth days. Very nearly 2 of our years pass for every single year that goes by on Mars. The seasons there are long and slow and patient, and patience, you will find, is the great theme of everything that happens out there. For all that it is small, Mars holds some of the largest and most dramatic places in the entire solar system. There is a volcano there called Olympus Mons, and it is the biggest volcano known anywhere among the planets. It is so wide that it would cover the whole state of Arizona, and so tall, rising up out of the plain in a gentle dome, that it stands about 2.5 times the height of Mount Everest. If you were somehow set down at its base, you would never even see its peak. The summit would be hidden far above you, lost beyond the curve of the slope, climbing up and up into the thin pink sky. And there is a canyon on Mars, a vast wound in the surface, so long that it would stretch all the way across the United States from one coast to the other, and in places deep enough to swallow the tallest mountains we have. Beside these, the Grand Canyon back on Earth would look like a small scratch in the dirt. At each end of the planet, north and south, there are caps of ice, white and bright, that grow in the Martian winter and shrink back in the summer, breathing slowly in and out with the long seasons. Some of that ice is frozen water, and some of it is frozen carbon dioxide, what we would call dry ice. And circling the planet are 2 tiny moons, far smaller than our own, 2 little lumps of dark rock named Phobos and Deimos, so small and so close that one of them races across the Martian sky and sets in the wrong direction, rising in the west and going down in the east. Several times in a single day. It is a strange and beautiful place, this small red world. And for a long time, all we could do was look at it from afar and wonder. Now, Mars looks dead today. Cold, dry, dusty, still. But here is the question that has pulled at us for more than a century. Was it always this way? When we first turned good telescopes toward Mars, we saw faint markings on its surface, and some astronomers convinced themselves they saw straight lines, channels, even canals, as if some thirsty civilization had carved waterways across a dying world. That turned out to be a trick of tired eyes straining at the very edge of what they could see. There were no canals. There were no Martian engineers. But the deeper question would not go away. Because when we looked closely, we began to see shapes that any river on Earth would recognize. There are valleys on Mars that branch and wind exactly the way river valleys branch and wind here. There are wide, flat basins that look for all the world like the beds of ancient lakes. There are deltas, fan-shaped spreads of sediment, just like the ones that form where a river slows and dumps its load of sand into a sea. From orbit, looking down, it is hard not to feel that you are looking at a landscape carved by water. Water that is gone now. Water that vanished a very, very long time ago. And that is the mystery. That is the thing worth losing sleep over. Or rather, the thing worth finding sleep over. If Mars was once warm and wet, then for a long stretch of its history, it may have looked a great deal like the early Earth. And on the early Earth, in warm, shallow water, life began. So the question becomes almost unbearably simple. If 2 worlds started out so alike, did life begin on both of them? Are we alone? Or did this cold, red desert once hold something soft and living in its seas, before the water drained away and the cold crept in? You cannot answer a question like that from a telescope. You cannot answer it from orbit. To answer it, you have to go down to the surface. You have to walk across the ground and pick up the rocks and turn them over in your hands and read the long, slow story written inside them. The trouble is, no human being has ever stood on Mars. So we did the next best thing. We built hands and eyes and sent them in our place. We built rovers. And the rovers, you should know, did not come first. They stand on the shoulders of brave machines that went before them. Back in the year 1976, 2 landers called Viking touched down on the Martian surface, the first craft from Earth ever to settle softly onto that ground and survive. And they sent home the very first pictures taken from the surface of Mars, a strange, rust-colored plain scattered with rocks beneath that pale, tea-colored sky. They did not move. They simply sat where they landed and looked around and scratched at the soil beside them. But they proved it could be done. They proved we could reach across the dark and set something down gently on another world. Then, on the 4th of July, 1997, a small craft called Pathfinder bounced down onto Mars wrapped in airbags, the first time that bouncing trick had ever been tried. And out of it rolled a tiny rover no bigger than a microwave oven, named Sojourner. Sojourner was the first wheeled thing ever to drive on another planet. It crept only a short way from its lander, never going far, but it moved. It rolled across Martian soil under its own power, and in doing so, it opened a door that all the larger rovers would later walk through. After that came a lander called Phoenix, which set down near the cold northern edge of the planet and dug a little trench into the frozen ground, and found, just beneath the surface, what no one had ever touched on Mars before: ice. Frozen water, hiding right there under the dust. Each of these machines learned a little more, and each handed what it learned to the next, the way explorers have always done, leaving notes and maps for whoever would follow. Behind all of this, behind every wheel and wire and camera, there are people. It is easy to forget that. It is easy to think of a spacecraft as a cold machine, a thing without a heart. But every bolt on those rovers was tightened by a human being who cared. Often a human being who would lie awake at night worrying about it. One of those people is an engineer named Kobe Boykins. He worked at the Jet Propulsion Laboratory in California, the place NASA built decades ago to send machines out into the solar system. His job, among other things, was to design the solar arrays, the great folding wings that catch the faint sunlight on Mars and turn it into power. Without those wings, the rovers are just dead weight. With them, the rovers live. He once described what it feels like to watch the moment those wings unfold on Mars. The moment after landing when the rover wakes up and reaches out and spreads its panels to the sun. He said that he had seen it happen in animation and in real data 1,000 times. And it did not matter how many times he saw it. Every single time, when it worked, he felt a jolt of joy. Because, as he put it, his team designed that. And if it did not work, they had a very, very bad day on Mars. There is something deeply human in that. The engineer who builds the wing and then has to wait, helpless, across 100 million miles of empty space to find out whether the wing will open. You cannot reach out and fix it. You can only build it as well as you possibly can, and then let it go, and hope. That is the feeling to hold on to as we follow these machines. Behind their patient mechanical crawl, there is a room full of people who love them, who name them, who talk about them the way you might talk about a brave and stubborn animal. As you will hear, the engineers gave the first two rovers nicknames. They called one of them the Bad Sister, and one of them the Good Sister, with the same mix of exasperation and affection you might use for family. These are machines. But to the people who made them, they are very nearly alive. So let us follow them. Let us begin with the first two, the twins, the pair of rovers called Spirit and Opportunity. They were built to do the same job, and they were built almost exactly alike. So think of them as twins. Each one was about the size of a golf cart, standing on 6 wheels, with a tall mast rising up like a neck and a pair of camera eyes set right at the top. And here is a small, lovely detail. The engineers set those eyes at a particular height on purpose. They placed them about 5 feet 2 inches off the ground. That is roughly the height of a person's eyes when they are standing. They did this so that when the rover looked around and sent its pictures home, the view would feel human. It would feel the way the world would look to you if you were the one standing on Mars, turning slowly in place, taking it all in. The journey to Mars begins, as all such journeys do, with fire and noise. The 2 rovers were carried up, one at a time, on top of a rocket called the Delta II, a tall, slender machine built by the Boeing company. It had 3 stages, 3 separate engines stacked one on top of another, each one doing its work and then falling away when its job was done. And around the base of the first stage were 9 smaller booster rockets, strapped on like extra muscles, to give the whole thing the hard extra shove it needed to break free of the Earth and fly toward another planet. Imagine the countdown. 5, 4, 3, 2, ignition. And then that low rolling thunder you feel in your chest more than you hear in your ears, as the rocket climbs up off the pad on a column of flame. Within about a minute and a half, it is already in orbit around the Earth, racing around our planet faster than any bullet. The strapped-on boosters have done their work and fallen away, tumbling back down toward the ocean, where, the engineers like to say, they sink and quietly become a new home for the fish. Then the first stage burns out and lets go, falling back to the sea. The second stage lights. But up there, with so much of the rocket gone, the spacecraft has very little to keep it steady, the way a long arrow flies true, but a short stub of one wobbles. So they do something clever. They spin it. They set the whole spacecraft turning, about 12 slow rotations every minute, like a quarterback putting a tight spiral on a thrown football. That gentle spin holds it steady and pointed true. The third stage lights, and that final push sets the spacecraft on a long curving path that will carry it away from the Earth entirely, out across the dark, toward the place where Mars will be 7 months from now. And then comes the strangest part of the whole trip: the waiting. The engineers have a name for it. They call it the quiescent period, which is just a soft scientific word for the quiet time. For 7 long months, there is almost nothing to do. The spacecraft simply coasts through the enormous emptiness between the planets, traveling at something like 16,000 miles per hour, and yet seeming, against the vastness around it, to barely move at all. There is no air out there, no friction, nothing to slow it down, and nothing to speed it up. It just falls endlessly along the invisible curve that gravity has set for it. 7 months of silence. 7 months of patience. 7 months of a tiny made thing drifting through a dark so wide it has no edges. It helps, sometimes, to try to feel the size of that emptiness, though the mind can barely hold it. The space the rover crosses is not like the distance between 2 cities, or even 2 countries. Light itself, the fastest thing there is, the thing that crosses our whole world in the blink of an eye, takes long minutes to make the same trip. And the rover is so very small against all of it. If you could somehow stand out there in the middle of the journey and look for the spacecraft, you would never find it. It would be a single speck, smaller than a grain of dust, hanging in a darkness that goes on and on past every star you can see and far, far beyond. And yet inside that speck, everything matters. Every wire, every weld, every instruction it carries. A small, perfect thing, made with great care, falling silently through the dark, holding inside it all our hopes of touching another world. There is something restful in that thought, if you let it settle. The way something so tiny can carry so much, simply by being well made and patient and pointed in the right direction. But that quiet time, it turns out, is not always so quiet. And here is where the story of Spirit, the one they called the Bad Sister, takes its first frightening turn. During those 7 months of coasting, while Spirit was halfway between the worlds, the sun threw a tantrum. There was an enormous solar flare, one of the largest bursts of energy the engineers had ever seen the sun produce. Think of it as the sun burping, a great violent belch of radiation and high-speed particles flung out across space in every direction. And some of that storm came washing over the little spacecraft as it drifted along, defenseless, far from any help. This is the kind of thing that can scramble a computer's mind. The radiation flips tiny switches inside the machine, corrupts its memory, confuses its thinking. And so the engineers did something they had never done before with a spacecraft flying out into deep space. They turned it off. They sent the command across all those millions of miles to shut the computer down completely. And then they turned it back on again. They rebooted it, the same way you might fix a frozen phone. Except this phone was somewhere out beyond the orbit of the Earth, hurtling toward another planet. And after a terrible pause, the machine woke up. And it called home, and it said, in effect, I am here. And in the control room, You can imagine the held breath let go all at once. Oh, thank goodness, thank goodness, thank goodness. That should have been the end of the trouble. But Spirit had one more scare to give them, and this one came after the landing. We will come back to it. First, we have to get her down onto the ground. And the way these first rovers landed is one of the most wonderfully strange pieces of engineering anyone has ever attempted. Coming home to Mars, after 7 months in the dark, the spacecraft sheds the parts it no longer needs, the cruise stage that has been pointing it true all this time, and falls toward the planet at about 16,000 miles per hour. Then it touches the very top of the Martian atmosphere, and even though that air is thin, the spacecraft is moving so fast that hitting it is like hitting a wall. The friction is ferocious. The front of the spacecraft, the heat shield, begins to glow, and it climbs to something like 2,900 degrees Fahrenheit, hot enough to melt most metals, hot enough that it carves a glowing hole through the sky as it comes down. Now the engineers begin what one of them lovingly called reverse origami. Origami is the art of folding paper into shapes. Reverse origami is the spacecraft unfolding itself, step by careful step, each piece opening at exactly the right moment, with no one there to help. First, a parachute snaps open, an enormous one, built to work even though the spacecraft is still moving faster than sound. The parachute grabs the thin air and begins to swing the spacecraft from coming in flat and fast to falling more straight down toward the ground. It slows to somewhere between 300 and 400 miles per hour, which sounds fast, and is, but is so much slower than before. The heat shield drops away, because you do not want all that stored heat soaking back into your delicate rover. And then the cleverness begins in earnest. The rover is lowered out of the shell on a long tether, dangling beneath it like a spider on a thread. And then, all around the rover, great balloons inflate, airbags, just like the ones in a car, except these wrap the whole machine in a soft cocoon. They blow up in about half of 1,000th of a second, faster than you could ever blink, faster than thought. At about 130 feet above the surface, small rockets fire to bring the falling speed down to nothing, to zero, just for an instant. And then the tether is cut, and the rover, wrapped in its balloons, drops the last little way and hits the ground. And it bounces. It bounces high. That first bounce can carry it up higher than the Empire State Building. And then it comes down and bounces again and again. Each bounce a little lower, a little gentler. The energy bleeding away with every touch. The whole bundle can roll and tumble across the surface for between 1.5 miles and 2 miles before it finally rocks to a stop. Picture that. A made thing from Earth, sealed inside a ball of airbags, bouncing across the floor of another world like a child's toy thrown down a hill, while a room full of engineers 100 million miles away grip the edges of their desks and wait. Here is something to sit with quietly. All of that. The searing entry, the parachute, the rockets, the bouncing, all of it happens entirely on its own. The rover does it alone. There is no time to ask Earth for help, because a radio signal takes somewhere between 3 minutes and 22 minutes to cross the gulf between the planets, depending on where the two worlds happen to be in their orbits. By the time anyone on Earth heard that the landing had begun, it would already be long over, the rover already safe, or already broken, on the ground. So the engineers can only watch the signals trickle in, knowing that everything they are seeing already happened minutes ago, that the verdict is already in, that there is nothing left to do but wait to learn what already came to pass. And when the bouncing stops, the rover senses that it has finally come to rest, and it lets the air out of the bags, deflating them so they sag down out of the way. Then the petals open. The lander it rode down in is shaped a little like a flower bud, with 3 panels folded up around the rover. And now those petals slowly swing down and outward, and the machine inside is righted, set upright, lifted gently into the daylight of a new world. What you would see happen in a few seconds in an animation takes about 45 minutes in real life. Everything out there is slow. The petals open over many long minutes. Then the rover's own solar wings unfold, those panels that the engineer Kobe Boykins designed and worried over, reaching out to drink in the pale sunlight. And this is the moment he loved. The moment that, when it works, sends that jolt of relief through everyone watching. The wings open. The batteries begin to charge. The rover is alive. Then the tall camera mast rises up, lifting those eyes to that careful height of about 5 feet 2 inches. The antenna unfolds, the one that will let the rover speak directly back to Earth across all that distance. And the very first thing the rover does, the very first thing, is the most human thing imaginable. It looks around. It turns slowly in place and takes a panoramic picture of wherever it has landed, stitching together a full circle of this strange new place. And it begins sending that picture home. Because when you wake up somewhere you have never been, the first thing you want to know is simply, where am I? What does it look like here? The next day, the rover stands up fully, deploying its front wheels, changing its whole posture from a crouched landing position to a standing one. And then, finally, it has to do the thing it came all this way to do. It has to drive down off the lander and put its 6 wheels on the actual soil of Mars and begin to roll. Spirit was the first to do it, and this is where she earned her nickname. They called Spirit the Bad Sister, not because there was anything wrong with her, but because of the trouble she gave them. The way a beloved but difficult child earns a teasing name, she drove off her lander and rolled up to her very first rock, a rock the team had named Adirondack. She reached out her robotic arm to touch it, to study it. And the moment she touched it, she went silent. She stopped calling home. You can imagine the dread in that control room. They had crossed the solar system. They had survived the solar storm, the searing entry, the bouncing landing, the unfolding. And now, at the very first rock, the rover had simply gone quiet, like a small creature that suddenly refuses to speak. What had they done? What had gone wrong? Here is what had gone wrong. And it is almost tender in how ordinary it is. Remember that quiet time. Those 7 months of coasting through space. During all that time, and during the landing, the rover had been faithfully recording every maneuver, every bounce, every shudder and turn. It wrote it all down into its memory. Every single thing it felt, dutifully, completely. And then it kept on recording after landing too. And 8 days later, when it rolled up to that first rock and reached out its arm, its memory simply filled up. There was no room left, and a computer with a full memory cannot think. It cannot even properly start itself up. So it froze and fell silent. The fix was strange and gentle. The engineers, once they understood, told the little machine to let go. They commanded it to erase its memory, to throw away all those careful recordings of the long, quiet crossing, all the bounces and the maneuvers, and to clear its mind. And once it did, once it released all of that, it woke right back up, cheerful as anything, ready to work. I am here, it seemed to say. I am all happy. Tell me what to do. Show me the rock. There is a small piece of wisdom hidden in that. If you want one as you drift off tonight, sometimes a mind cannot move forward because it is too full. It is holding too much, recording everything, gripping every detail of the long journey. And sometimes the kindest thing, the thing that lets it wake up and work again, is simply to let some of it go, to clear the memory, to release the weight of everything it has been carrying. You do not have to hold all of it tonight either. You can let it go. Now we come to the heart of why these little machines matter so much. Because Spirit and her sister Opportunity were not built to drive far or to live long. They were built to last for about 90 days and to travel about a third of a mile, a little more than 2,000 feet. No farther. 90 days. That was the whole promise. That was all anyone asked of them. After 90 days, the engineers expected the dust to settle thick on the solar wings, blocking out the sunlight, starving the rovers of power, until they slowed and stopped and froze and fell silent forever in the cold. That is not what happened, not even close. Spirit, the bad sister, the one who scared them at the very first rock, stayed alive and talking for more than 5 years. 5 years. When she was built for 3 months. In all that time, she crept across the surface and traveled a little less than 5 miles. It does not sound like much. 5 miles. The distance you might walk in an easy afternoon. But she did it inch by inch, soul by soul, on a world where the nearest mechanic is 100 million miles away. And she did it for 60 times longer than anyone promised. And Opportunity, the good sister, the one who landed a month after Spirit, she did something even more astonishing. She rolled across Mars not for months, not for years, but for more than a decade and a half. She kept going and going and going, long after Spirit had fallen silent, long after almost everyone had stopped expecting it. By the end, she had driven more than 25 miles across the surface of another planet, and her final distance was about 28 miles, the length of a marathon, all of it logged a few careful feet at a time. A machine built to last 90 days lived for 15 years. Sit with how extraordinary that is. How did they last so long? Part of it was simply that they were built so very well by people who cared, but part of it was a gift from Mars itself, and it is a lovely thing to know. The engineers, looking down from orbit, had long seen strange long tracks scrawled across the dusty surface, and they had guessed these were made by dust devils, small whirlwinds, little spinning columns of air that wander across the Martian plains, the same way they wander across deserts on Earth. They had never actually seen one happen, but every so often, the rovers would suddenly start making more power, their solar wings drinking in more sunlight than the day before. And the engineers slowly realized what was happening. A passing dust devil, a little Martian whirlwind, was sweeping over the rover and brushing the dust off its wings, cleaning them, wiping them clear. And with clean wings, the rover could drink in more light, make more power, and keep right on working. There is something almost like kindness in that image. The planet that should have killed these machines, that should have buried their wings in dust and let them die on schedule, instead sent its little whirlwinds again and again to dust them off and keep them alive. The rovers themselves seemed to feel it. In the words the engineers used, the dust devil would come by and clean off the solar arrays and make them happy, and now the rover could keep doing its science, as if the machine were grateful, as if Mars, in its own strange way, had decided to let them stay. So now we have two small machines, alive far longer than they should be, rolling slowly across the red plains. What did they actually find? This is the first great discovery of our story, and it is the answer to that aching old question. Was Mars ever wet? Their whole job, you see, was to follow the water. Spirit and Opportunity were sent out as roving geologists, which is just a way of saying they were sent to study the rocks. Because rocks, remember, a rock holds the history of the place it formed in, the way a tree's rings hold the history of the years it grew through. So the rovers went from rock to rock, and in the words of the team, they would go up and taste the rocks, touch the rocks, feel the rocks, break the rocks if they could, all to ask one question of each stone. Do you remember water? Were you here when there was water? The first thing they find is that the answer is yes. And they find it in the most wonderful accidental way, through a failure. This is the broken wheel from the very beginning of our story tonight. And now we can finally tell it properly. Spirit was climbing a hill. A rise the team had named Husband Hill. And as she climbed, one of her 6 wheels stopped working. It simply locked up and would not turn anymore. Now, for most machines, a dead wheel is the end of the road, or close to it. But Spirit did not stop. She kept driving, dragging that dead wheel behind her like a stubborn old soldier limping on. And as she dragged it, the locked wheel plowed a long, shallow trench through the Martian soil, scraping away the dry, dusty surface and turning over the dirt underneath. When the engineers looked at the pictures of that trench, they saw something that stopped them cold. The soil that the dragging wheel had turned up looked different. It was brighter. It reflected light differently than the surface around it. and when they studied it more closely, they realized what they were looking at. The wheel had scraped down to soil rich in salt. Bright, pale, salty soil, hidden just beneath the surface, exposed only because a broken wheel happened to drag through it at just the right spot. Why does salt matter so much? Because of how salt gets left behind. Think of a puddle of salt water drying in the sun. As the water slowly evaporates and disappears, it cannot take the salt with it. The salt is left behind, more and more concentrated, until at last, when the water is gone, there is a crust of salt where the puddle used to be. That is what the rover had found. As the team climbed higher up the hill, they watched the saltiness of the soil change, growing saltier in just the pattern you would expect if water had once stood here and slowly, over ages, dried away, leaving its salt behind. The water got saltier as it receded, and the soil remembered. It was a failure, a dead and dragging wheel. That told them the most beautiful thing. There had been water here, real water, and it had stood long enough and dried slowly enough to leave its signature behind in the salt. Her sister, Opportunity, found her own evidence on the far side of the planet. Opportunity had bounced down into a region called the Meridiani Plains and rolled into a crater, and she spent her long years exploring craters, eventually working her way into a great one called Endeavor. There, deep inside, she found clays. Now, clay is a humble thing, the stuff of mud and pottery, but clay is precious to a geologist on Mars because clay forms in water. It forms when water works on rock over long stretches of time, gently rotting it down into soft, fine particles. To find clay is to find the fingerprint of water that lingered, water that stayed. And Opportunity found it spread widely, telling the team that across these plains there had once been water, and not just a splash of it, but deep water, water that lasted. And then there is one small, lonely discovery that I love, because it is so unexpected. Opportunity, having traveled 300 million miles to reach Mars, bounced down into a crater that was, by her account, almost completely empty. Nothing there. Just bare ground, and one single rock sitting in the middle of it. And when she studied that one rock, it turned out to be a stranger. It was not from Mars at all. It was a meteorite, a chunk of metal and stone that had fallen out of the sky from somewhere else, from another corner of the solar system entirely, and come to rest on the Martian plain to wait, who knows how long, for a small machine from Earth to roll up and find it. Two travelers, both far from home, meeting by chance in an empty crater on a distant world. Where exactly that rock came from, no one can say for certain, but there it was, and there she was, and for a moment, they kept each other company. Opportunity gave us one more gift that is easy to overlook but rather wonderful. One day she pointed her cameras up at the Martian sky and took a picture of the weather above her, the haze and the thin, high clouds. At the very same instant that a spacecraft circling far overhead took a picture of that same patch of sky from above. It was the first time we had ever managed that. A view of the Martian air from the ground and from orbit at the very same moment. Like having a doctor listen to the same heartbeat with two instruments at once. With both views together, scientists could begin to understand the Martian weather in a way they never could before. Watching the dust and the clouds and the thin air not as flat pictures, but as a living, moving sky, seen from below and above in the same breath. So that is the first great discovery. The answer the twins brought home. Mars was once a wet place. Long ago, water ran across these plains and stood in these craters and dried in these hills, leaving its salt and its clay behind like notes left for someone to find much later. The cold, dry desert we see today is the ghost of a wetter world. And that changes everything, because where there is water, there might once have been more than water. Now, let us change gears, the way the talk does, and turn to the third rover, the big one, the one that took everything the twins had learned and pushed it further. Let us turn to curiosity. If Spirit and Opportunity were the size of golf carts, Curiosity is the size of a small car. Picture a vehicle about as big as a compact car, rolling across Mars on 6 chunky wheels, with a tall mast and a long jointed arm, and mounted up high, a head that can shoot a laser. Curiosity launched on the 26th of November, 2011, and came down onto Mars on the 5th of August the following year, 2012. And it carried a different mission than its smaller cousins. The twins were roving geologists, sent to follow the water. Curiosity was sent as something more like a roving biologist. Its job was not just to find old water, but to ask a deeper question. Were there once places on Mars that could have supported life? Not whether life was there, the rover could not prove that, but whether the conditions were right, whether the basic ingredients, the building blocks, were ever in place for life to take hold. Because Curiosity is so much heavier than the twins, it could not ride the same small rocket. It launched on a larger one, an Atlas rocket built by the Lockheed Martin company, with just 2 stages instead of 3. And because of the way Earth and Mars were arranged that year, and because of the weight, it traveled a little more slowly, at about 14,500 miles per hour. All the way there, the spacecraft kept its batteries topped up and carefully managed, charging them and discharging them and holding them at around 80%. The way you might care for a battery, you need to last a very long time. But the truly new thing, the thing that makes Curiosity's arrival one of the boldest pieces of engineering ever flown, is the way it landed. Curiosity was far too heavy for airbags. You cannot wrap a small car in balloons and bounce it across the ground. So the engineers dreamed up something that sounds, frankly, insane. And then they made it work on the first try, on another planet, with no chance to practice. It begins the same way. The searing entry, the heat building on the shield, the great parachute snapping open in the thin, fast air, the heat shield falling away. But this time, instead of lowering the rover on a tether into a cushion of airbags, they did something else. They added a new camera, pointed straight down at the ground, taking pictures at about 32 frames per second as the spacecraft fell. The spacecraft looked at those rushing images of the surface, layered them one on top of another, and worked out, all by itself, exactly where it was going, how fast, and whether there were any dangerous rocks or slopes in the way. A falling machine, reading the ground beneath it like a face, deciding where to set itself down. And then, when it had chosen its spot, the rover did not bounce. Instead, a separate stage, a kind of rocket-powered platform, fired its engines and held itself steady in the air, hovering above the surface like some impossible flying machine, and from beneath it, on 3 long cords and a single cable for talking, it gently lowered the rover the rest of the way down, like a mother lowering a child to the ground on a swing. The cords paid out. The rover's wheels touched the soil. Ever so gently, the cords went slack, and the instant the platform sensed that slack, that the rover was safely down and standing on its own wheels, it cut the cords, and the flying platform fired its rockets and flew away. Off, to crash somewhere far enough off that it could not hurt the rover it had just delivered. It was designed to fly itself about 1/3 of a mile away before coming down, because, as the engineers dryly noted, it would be very bad indeed if it came back and crashed on top of them. The whole thing, the entry and the parachute and the hovering and the lowering, lasted just a few terrifying minutes. And once again, every bit of it happened on its own. Far too fast and far too distant for anyone on Earth to help. The engineers could only sit in their darkened room and watch the signals come in, knowing the whole drama was already over, already decided, minutes before they would ever know. And it worked. The flying platform set the little car down softly on the floor of Mars, cut the cords, and flew away to its lonely end. And Curiosity stood there, whole, on its 6 wheels, ready, because it landed standing on its own wheels. Curiosity did not even need to climb down off a lander. It was ready to go on the very first day. It raised its mast, the one that holds its eyes, and unfolded its antenna, a beautiful piece of equipment that, charmingly, had been given to NASA as a gift by Spain. And then it began to look around, and to drive, and to do its strange and patient work. Let us talk about that work, because Curiosity carries tools the twins never had, and they are wonderful. The first thing to know is that Curiosity can shoot a laser. Up on its head is an instrument that fires a tightly focused beam at a rock, even a rock several feet away. And the beam strikes with such intensity that it burns a tiny spot on the rock's surface, vaporizing it, turning a little of the stone into a puff of glowing gas. And then the rover studies the light coming off that glowing gas. Because of a deep fact about nature, every element gives off its own particular colors of light when it burns, like a fingerprint made of light. So by reading the colors in that little puff of gas, Curiosity can tell what the rock is made of, what elements are inside it, all without ever rolling over to touch it. The twins had to drive up to every rock and reach out and touch it to study it. Curiosity can simply look at a rock across the way and zap it, and read its secrets from a distance. People sometimes imagine the rover blasting away at Mars with some kind of dramatic weapon. The truth is gentler and more curious than that. It burns a spot the width of a pinprick, and then it reads the smoke. The second new tool is a drill. Mounted on the end of Curiosity's long arm is a drill that can bore down into solid rock. And this was the very first time anyone had ever drilled into the rock of another planet by remote control, with no human hand to guide it. We had drilled on the moon before, but human beings were standing right there to do it. This was different. This was a machine 100 million miles away, drilling into Martian stone on its own. And it is slow, achingly slow. Making a single small hole took about 4 weeks. 4 weeks for one hole. But once the hole is drilled, the rover collects the powder it has ground up, draws it inside its own body, and sifts it down to particles only a few thousandths of an inch across, fine as flour. So fine you could barely see a single grain. Then it delivers that fine powder to a set of small laboratories tucked inside the rover, where it can be heated and tested and read. There is even an instrument that shines a special kind of light called X-rays through the powder and watches how the light scatters, to work out how the atoms inside the rock are arranged, the hidden crystal structure of the stone. And that arrangement, the secret geometry of how a mineral is built, tells the scientists an enormous amount about how and where that rock formed and whether water was involved in making it. The rover, in other words, is a full geology laboratory on wheels, carrying inside its body the kinds of machines that would fill a room back on Earth, and doing it all alone, on Mars, very slowly, very patiently. And it is slow in its driving too, slower even than the twins. Curiosity's top speed is about 2 inches every second. 2 inches, less than the length of your thumb in a whole second. At that pace, the engineers will tell you, it takes about 45 minutes just to cross the length of a football field. Imagine that. 45 minutes to travel 100 yards. You could walk it in less than a minute. But the rover is not in a hurry, and it cannot afford to be. As one of the engineers put it so beautifully, when you are 300 million miles away from the nearest gas station, it is perfectly all right to go slow. There is no rushing on Mars. There is only patience and care, and the long, slow accumulation of one careful step after another. It is worth picturing how a single day in the life of the rover actually goes, because the rhythm of it is gentle and strange. The rover does not decide for itself where to drive each morning. Far away on Earth, while the rover sleeps through the Martian night, a team of people study the pictures it sent home the day before, and they argue and plan and slowly agree on what it should do next. Drive to that rock, reach out the arm, take these pictures. Then they write all of it down into a careful list of instructions and beam it across the Gulf, so that when the Martian sun rises and the rover wakes and warms its electronics, the plan is already waiting for it. It carries out its day alone, with no one watching in real time, because no one can. And at the end of its working day, before it sleeps again, it sends home everything it saw and did. And the people on Earth begin planning the next day all over again. In the earliest years, the team did something almost dreamlike to keep pace with their distant machine. Because a Martian day runs about 39 minutes longer than an Earth day, they tried to live on Mars time. Their workdays slid a little later with each passing day, drifting slowly around the clock, until they were sleeping through the afternoon and coming to work in the dark of night, all so they could be awake whenever the rover was awake, 100 million miles away. For a while, a small group of people on Earth lived by the clock of another planet, their own days quietly out of step with everyone around them, all for the sake of a small machine they had come to love. There is a kind of devotion in that, slow and unglamorous and real. Let me tell you about the rover's wheels, because they hold one of the quiet dramas of this whole story. From a distance, those 6 wheels look like solid blocks of metal. They are not. The outer shell of each wheel is aluminum, but it is thin, only about as thick as 7 sheets of paper stacked together. And inside, threaded through, is titanium, a tougher metal, there to give the wheel a bit of spring, a slight forgiving flex, so it can take the shocks of the rough ground without shattering. It is a clever, delicate design, and it would be tested, hard, by the cruelest ground curiosity ever crossed. The way those wheels are joined to the rover is worth a quiet moment too, because it is a small marvel that all the rovers share. The wheels hang on a system of pivoting arms that the engineers call a rocker bogie. And the whole point of it is to let the rover crawl over rough, broken ground without ever tipping over. When one wheel rides up over a rock, the arms simply flex and shift, and the rover's body stays nearly level, the way a patient camel sways and stays steady over uneven sand. On Curiosity, all 6 wheels have their own motors, so all 6 can drive at once, and 4 of them can also turn, swiveling so far that the rover can spin completely in place, turning around its own center like a slow dancer, without rolling forward an inch. It can climb over rocks and steps more than a foot tall, about the height of your knee, just clambering patiently over them, one wheel at a time. And on Curiosity, those wheels do double duty. They are not only for driving, they are also the landing gear, the legs the rover stands on the instant the sky crane sets it down. Every part, you see, asked to do more than one job, because every ounce that flies to Mars is precious. But before we get to that trouble, we should follow Curiosity to the place it was sent, and understand why. The rover came down in a great bowl called Gale Crater. And the reason the scientists chose Gale Crater is that, rising out of the middle of it, there is a mountain, a tall, layered mountain that the team named Mount Sharp. It stands about 3.5 miles high, and it is made of layer upon layer of rock, stacked up like the pages of a closed book. And that, the layers, is the whole point, because on a mountain like that, the layers near the bottom are the oldest, laid down long ago, and each layer above is a little younger than the one below it, all the way to the top. So if you could drive up that mountain, slowly, layer by layer, you would be driving forward through time. The bottom layers would tell you about the most ancient Mars. And as you climbed, each new layer would tell you about a slightly later age, the way the rings of a tree or the pages of a book carry you forward through the seasons and the years. The plan was simple to say and very hard to do. Land near the mountain, drive to it, and then read it, layer by layer, climbing up through the history of Mars itself, looking for the chapters when this place might have been gentle enough and wet enough for life. And here is the second great discovery of our story, and it came astonishingly fast. Within the first 3 months at Gale Crater, almost as soon as it arrived, Curiosity was able to say 2 enormous things. First, that Gale Crater had once been wet, that water had been here, and second, that this place could have sustained life. Not that life was here. The rover could never prove that, but that all the chemical ingredients life needs were present. That if living things had been here, in the ancient past, this place could have kept them alive. The building blocks were all in place. The water had been here. The conditions had been right. In just 3 months, the big rover had answered the question it crossed the solar system to ask. There had been, somewhere in the deep past of this cold red world, a place where life could have lived. The team found riverbeds, too, or the long, dry ghosts of them. There are images Curiosity sent back of rounded pebbles, cemented together in exactly the pattern you find in the bed of an old stream on Earth, where running water tumbles stones along and smooths their edges and packs them together. Lay a picture of a Martian stream bed beside a picture of an earthly one, and you can hardly tell them apart. Water-shaped both, the same gentle physics, the same patient flow, on 2 different worlds. There is a tender, almost playful side to Curiosity too, that I cannot leave out. After it landed, it began, of all things, to take pictures of itself, selfies, on Mars. The first one was clumsy, just the rover's own shadow stretched across the dirt, as if it were still learning how to hold the camera. But in time it grew rather good at it, swinging its long arm around to photograph its own body from the outside, stitching together portraits of a lonely machine standing on a red and empty plain, with the mountain rising behind it. And in one quiet image, the team paid homage to the explorers who came before. They placed, side by side, a picture of the boot print that Buzz Aldrin left in the gray dust of the moon all those years ago, and a picture of the track that Curiosity's own wheel pressed into the soil of Mars. One footprint of a man, one wheel print of a machine. Both of them marks left by creatures from Earth in places no earthly thing had ever touched before. A small reminder that this rover, crawling alone across Mars, is part of a very old story. The story of a curious species that keeps leaving its prints a little farther from home. And when Curiosity finally reached the foothills of the mountain and began to drill, it kept finding the signs. At a place the team called Pahrump Hills, near the gateway to Mount Sharp, the rock looked soft and clayish, and woven through it were pale lines, like veins, like something that had seeped in and hardened. And the mineral they believe they found there has a name: hematite, an iron mineral that here on Earth forms in water. To find hematite is to find yet another place that was once wet, layer after layer, hill after hill. The story kept repeating itself. Water was here, water was here, water was here. Now, about that cruel ground I promised to tell you about. As curiosity drove toward the mountain, it crossed regions that frightened the team, places more dangerous than anything the twins had ever met. With spirit and opportunity, when the rover met a rock, it could usually just nudge it aside, or roll over it, or push it out of the way. But in these new regions, the rocks were cemented hard into the ground, locked in place, immovable, and they had been shaped by an endless wind into something terrible. The scientists used a word for them: ventifacts, wind-carved rocks. Imagine a place that was once covered with water, and as the water slowly drew away, the wind moved in and began to work the exposed stone, blowing fine grit against it for age upon age, sharpening it the way you might sharpen a blade against a stone, until the rocks stood up out of the ground like rows of teeth, sharp, hard, unforgiving teeth. And curiosity had to drive over them, and those thin paper-layered aluminum wheels, so clever, so delicate, began to take damage. The sharp rocks punched holes in them. When the team looked at the pictures of the wheels, they saw the punctures growing. And worse, they understood the deeper danger. Each time a wheel rolls and takes the weight of the rover, the metal flexes and strains, and tiny cracks begin to spread, the way a crack spreads slowly across a windshield. The engineers lay awake over this. How would the wheels fail? Would a crack run all the way across, and a whole piece of the wheel break off and fall away? And if a piece broke off, would it strike one of the many cables running near the wheels and do real harm? So they did something clever and humble, the way good engineers do. They began, on certain stretches of ground, to drive the rover backward. Driving backward shifts the load, takes some of the strain off the front wheels that were getting hurt, and spreads the wear more evenly across all six. It will not heal the damage, but it slows it, evens it, buys more miles, more sols, more time. And they discovered something else. Almost funny, almost a small consolation. The damaged wheels, the ones with holes in them, actually gripped better on soft sand. The holes gave them a little extra bite. So the wound that worried them so much turned out, on the dunes, to be a small gift. There is a lesson buried in there, too, if you want one, about how the very things that damage us can sometimes, in another kind of ground, become exactly what helps us hold on. There was one moment of pure engineering nerves I want to share, because it shows you how careful these people are, how much they worry over their distant machine. Curiosity came to a sand dune, only about 3 feet tall, just a small mound of sand. But the rover's belly sits only about 2.5 feet off the ground. So if that dune were nothing but soft, loose sand, The rover might sink in and get stuck, bellied out, helpless. On the far side of the solar system, the team argued about it for 2 whole days. 2 days. Over a 3-foot pile of sand. And in the end, they did not just charge across. They put one toe in, so to speak, edging the rover forward a little, then a little more, then driving up to the very top to peer over, and then backing all the way down again, before they finally took a breath and said, "All right, go." And the rover crossed it, lightly, the way they had hoped. But the care, the slowness, the willingness to spend 2 days fretting over 3 feet of sand, that is what keeps a machine alive on Mars for years and years. Patience, always patience. Curiosity's journey took it from its landing spot, a place the team named Bradbury Landing after a beloved writer of Mars stories, onward to a spot called Yellowknife Bay, and then to those Pahrump Hills at the foot of the mountain, the gateway to Mount Sharp. And there it began the long, slow climb that, in a sense, it is still climbing to this very day. Which brings us, gently, to where things stand now, in our own time. Because these machines have their own lifespans, their own ends, and it is right to speak of them softly and truly. Spirit, the bad sister, the one who scared everyone at the very first rock and then dragged a broken wheel into one of the great discoveries, met her end first. In time, she became stuck in soft soil, unable to free herself, parked at a bad angle as the long Martian winter came on, tilted the wrong way. Her solar wings could not catch enough of the low winter sun to keep her warm and powered. The engineers tried for months to free her and could not. Her last word came home in the cold, and after that, there was only silence. Her mission was formally ended in the year 2011. She had lived more than 20 times longer than her 90-day promise. She had earned her rest. Opportunity, the good sister, kept rolling for years more, all the way through, until the summer of 2018. And then Mars sent something even the dust devils could not save her from. A dust storm rose up. Not a local whirlwind, but a vast planet-wide tempest. One of the largest anyone had seen in many years, until the dust grew so thick that day turned to night across half the world and almost no sunlight could reach the ground at all. Opportunity ran on sunlight. With the sky choked black, her wings went dark and her batteries drained, and she fell asleep, waiting for the storm to pass. The very last picture she sent home, before the dark closed over her, was an image of the sun, dimmed almost to nothing, fading away into the gloom. And when the storm finally cleared, months later, and the engineers called and called and called, sending more than 1,000 tender messages out across the dark, she never answered. Her mission was declared complete early in the year 2019. By then, she had traveled about 28 miles, a marathon across another planet. And she had lived for nearly 15 years, A machine built for 90 days. Think of that as you lie there. A small, brave thing, built to live for 90 days, that opened its eyes on another world and refused to close them for 15 years, and whose last act was to take a photograph of a fading sun. And Curiosity, the big one, the roving biologist, is still alive, right now, in our own time, in the year 2026. It is still up there on the slopes of Mount Sharp, still climbing, still drilling, still reading the layered pages of that ancient mountain, layer by layer, sol by sol. It does not run on sunlight the way the twins did, so the great dust storms cannot starve it. It carries its own quiet warmth and power from a small source of heat that fades only very, very slowly. So it keeps going, the lone survivor of those early days, sending home its panoramas of strange Martian ridges and its quiet measurements, decades after it first touched the ground. As you drift off tonight, that little car-sized robot is out there in the dark and the cold, doing its patient work, alone, on a mountain on Mars. And it is not entirely alone anymore. Curiosity now has company on Mars, a younger cousin. The rover that the team was only just beginning to plan back when this story was first told has long since been built and launched and landed. It launched in the year 2020 and came down safely on Mars early in 2021 in a different crater, a place called Jezero, which the scientists believe once held a lake fed by a river, complete with the fan-shaped delta where the river spilled in. Its job is to look even harder for signs that life may once have existed, and, crucially, to gather up small, carefully chosen samples of Martian rock and seal them away, so that one day, on some future mission, they might be carried home to Earth, where the great laboratories of our whole world could study them in person. It even carried with it, folded up, a tiny helicopter, the first flying machine ever to lift off and fly through the air of another planet, rising up on whirling blades in that thin Martian sky and looking down on its rover from above. The story, you see, is still being written. The little machines keep going out. So why does all of this matter? Why send these slow, fragile, lonely robots across the dark, at such cost and such worry, to creep 2 inches at a time across a freezing desert? Part of the answer is the water and what the water means. By following the water, by tasting the salt that drying puddles left behind and the clay that lingering ponds left behind and the hematite that ran in the veins of the stone, these rovers proved something we only used to dream. They proved that Mars was not always the dead place it is now. Long ago, it was a world of rivers and lakes and standing water, a world that, at least in places, at least for a while, was gentle enough and wet enough that life could have taken hold. We have not found life there. We may never, but we have found the empty rooms where life could have lived. And that is a profound thing to know, that our small red neighbor was once a place where life was possible. It makes the universe feel a little less lonely and a little more full of doors that might somewhere have opened. Part of the answer is what these machines are teaching us for the day. Surely coming, when it is not a robot but a person who stands on Mars. Every wheel that punctured on a sharp rock. Every dune the team fretted over for 2 days. Every drill hole that took 4 weeks. Every solar wing that a dust devil saved. All of it is knowledge. Hard won. Carried home. That will help the first human travelers survive. The rovers are scouts. They are going first, into the danger and the cold and the dust, so that the people who follow will know the ground and know the risks and have a better chance of coming home. And part of the answer, I think, is simpler than all of that and closer to the heart. We send these machines because we cannot help ourselves. Because there is something in us, some old restless wonder, that cannot look up at a red point of light in the night sky and simply let it be. We have to know. We have to reach out. And since our own bodies are so fragile, and the distances so cruel, we build small, brave machines and pour our care into them and send them out in our place. And then we wait, helpless and hoping, across the dark, to learn what they will find. The rovers are our curiosity given wheels. They are our longing, made of aluminum and titanium and patience. And there is something else, quieter, that these machines gave us, almost without our noticing. They changed what Mars is, in our minds. For all of human history, Mars was a symbol, a red eye in the sky, a god of war, a blank screen onto which we painted our fears and our fantasies, our canals and our invading monsters and our lonely dreams. It was never a real place. It was an idea, but the rovers made it real. They sent home pictures of actual ground, actual rocks you could imagine kneeling down to touch, actual hills with names, actual sunsets going cool and blue over an actual horizon. They turned a myth into a landscape. Now, when you look up at that small red point of light, you can know, truly know, that there is a specific place up there, with a specific floor of dust and stone, and a small machine standing on it that we made with our own hands. Mars is no longer only a story. It is somewhere we have been. And that is a gift the rovers gave to every one of us, whether we ever think about them or not. Before that final image, sit for a moment with the names: spirit, opportunity, curiosity. These are not the names of cold machines. They are the names of feelings, of human longings. The very things that sent us reaching toward Mars in the first place. We did not have to name them at all. We could have called them by numbers and serial codes, but we did not. We gave them names a person could love, because somewhere deep down we knew that these little machines were carrying a piece of us, that they were our spirit and our opportunity and our curiosity, rolled out across the dark on 6 small wheels, and when they fell silent, the people who built them grieved. The way you grieve for something that was brave and faithful and is now gone, there is no shame in that. To love what we make, and to send it bravely into the unknown, and to mourn it when it stops. That is one of the most human things we do. Let me leave you, before we wind down, with the image that the engineer who told this story loved most of all. Near the end of her life, the twin Rover Spirit. From the top of that hill, the team had named Husband Hill, looked out toward the horizon as the day ended, and there, in the Martian sky, was the sun going down. The engineers also had pictures of Earth from Mars, our whole world reduced to a single faint star in the Martian evening, with, if you looked closely, the tiny speck of the moon beside it. And the thing that moved that engineer so deeply, the thing he could not wait for, was this thought, that someday, some person, a real living human being, will stand on the surface of Mars with their own 2 feet and watch the Earth set as a small, bright star, and then watch the sun itself go down over the red hills and feel the cold come on, and know that they are the first of us to ever see it with their own eyes. The rovers cannot quite see Earth set. Their cameras are not good enough. But they have shown us the way. They have stood in for us, out there on the edge of everything, and held the place, and waited, so that one day we can follow. Let it all settle now. Let the whole long story drift back through you, gently, like the slow turning of a rover taking in the view. It begins with a small red light in the night sky, a world we have watched and wondered about for thousands of years, and one quiet question: was it always dead, or was it once alive with water? It begins with people in a laboratory in California who could not let that question rest, who built small machines to go and find the answer, and who love those machines like family. It begins with fire, and a rocket, and a spacecraft set gently spinning like a thrown football, sent out across the dark on a 7-month fall toward another world. There is a solar storm in the long, quiet crossing, and a frightened little machine turned off and on again across millions of miles, waking to say, "I am here." There is a searing fall through a thin sky, a parachute snapping open, balloons blooming in less than the blink of an eye, and a rover bouncing across the floor of Mars like a child's ball thrown down a hill, while a room full of people grip their desks and wait. There is the unfolding, the petals opening over 45 slow minutes, the wings reaching out to the pale sun, the first turning gaze across a brand new world. There is Spirit, the bad sister, falling silent at her very first rock, her memory too full to think, and the gentle fix, the letting go, the clearing of all she had been carrying, so that she could wake and work again. There is the dead wheel she dragged up a hill, and the bright salty soil it turned up, and the beautiful truth it told, that water had once stood here and dried away and left its salt behind. There is opportunity on the far side of the world, finding clay, finding a lonely meteorite from somewhere else, finding deep water in the memory of the rocks. There are the little dust devils, the small Martian whirlwinds that came again and again to dust off the rover's wings and keep them alive far, far longer than anyone had promised. There is curiosity, the big one, lowered out of a hovering sky crane on 3 slender cords and set down softly and left to stand alone. There is its laser, reading the smoke of a burned rock from across the way. There is its drill, 4 weeks for a single hole, and its small inner laboratories sifting the powder fine as flour. There is the mountain it came to read, Mount Sharp, its layers stacked like the pages of a book, the oldest at the bottom, time itself written in stone. There is the answer it brought home in only 3 months, that this place was once wet and could once have held life. There are the cruel teeth of the wind-carved rocks, and the wounded wheels, and the patient, backward driving, and the 2 long days of worry over 3 small feet of sand. And there is the way it ends for each of them, and the way it goes on, spirit, stuck and tilted in the cold, falling silent in the winter, her work long since done. Opportunity, caught in a great dark storm, taking one last picture of a fading sun before she sleeps and does not wake, after 15 long years and a marathon of miles, and curiosity, still climbing, even now, even tonight, still reading the mountain, no longer quite alone, with a younger cousin in another crater gathering up pieces of Mars to send home one day, and a tiny helicopter that learned to fly in an alien sky. There is nothing to remember now. You do not have to hold any of it. Let the names go, and the numbers, and the dates. Let the salt, and the clay, and the laser, and the drill all soften and blur and drift away into the dark. The story will keep. The little machines will keep rolling whether you hold them in your mind or not. You can set it all down now, the way a rover clears its full memory, and feel how much lighter you are without it. Let your breathing slow. Let it move on its own, in and out, easy and unforced, like a slow tide coming up a quiet shore and sliding gently back. There is nothing to do with this breath, but let it come and let it go. Feel how heavy your body has become, settling down into the warmth around you. Your limbs growing soft and weighted, your shoulders dropping a little lower, the small tension in your jaw and around your eyes letting go. There is nowhere to drive tonight. There is no rough ground to cross. You can simply rest here, exactly where you are. The day is finished now, and you carried it well, all of it, every step. There is nothing left that you must solve, nothing that cannot wait until the light comes back. You are safe, and you are warm, and you are held, like a rover parked at the end of a long sol, powered down, waiting quietly in the dark for a morning that will come on its own, with no help needed from you at all. Far away, on a cold red mountain, a small brave machine is rolling slowly upward through the dark, 2 patient inches at a time, in no hurry at all, reading the long story of a world. It does not rush. It does not worry. It simply goes on, gently, into the night. And you can let yourself go gently into the night now, too. Rest now. Sleep deeply. And let the gentle dark hold you until morning.